All right, so let's go over a lot of problems from 7.4. I have a lot of them done, and we'll go over each of them in detail. So first thing, let's start with number one, just get the basic idea down. So the first problem is asking you to write it in sigma notation. So sigma notation wants you to just simply write the formula AN equals A1 R to the N minus 1 inside of a sigma. So A1 is 6, so I put a 6 here. And R is found by doing A2 over A1, so 24 over 6, which is just 4, so I put that here. And there are 5 terms, 1, 2, 3, 4, 5, so I put a 5 there. Now that 5 goes in for N in the formula. Please make sure you're writing the formula down. Remember, writing the formula down means you'll be more likely to get a good grade when it comes to test time because you'll be less confused about what to do and when to do it. So the 5 goes here for 5 and 5, so I put that there. And the 6, of course, is the same 6 that you see here, but not always. So be careful. It's really this 6 and not that 6. Keep that in mind. It's this 6, okay? And then the R value we found is here. R never changes, so R is the one static thing that you can always rely on. And then you type that into Desmos. So when you type it into Desmos, okay, just be careful that you're, watching what you're doing and actually practice it, right? Because, if you wait until the test to type these things in, you'll be surprised by what happens and little tricks and stuff. So I divide that by 1 minus 4, and people have brought up, do I need to put a parenthesis when it's positive? The answer is it's just a good habit. I always do it because when it's negative or a fraction, it's a huge deal. So the answer is 2046. All right, so from there, let's take a look at an infinity one. So how do I know the difference? Okay, look, do you see how this one is 1, 2, 3, 4, 5 and stops? There's no plus, there's no dot, dot, dot. Notice that this one goes on forever. So what happens when a problem goes on forever is that eventually if R is less than 1, which R would be A2 divided by A1, so 2/4 or a half, if this value right here is less than 1, then I have a convergent sequence. And what convergent means, okay, is convergent means decay, specifically to decay to 0. So eventually you're going to add nothing. Okay, and so when that happens, you can use this formula for infinity. A1 is, of course, what we're used to it being, right? A1 is just going to be this term right here that's written down, so I put a 4 there. And we already found R. R is a half, so we'll put 1/2 here. And this you can actually do by hand. I mean, you can use Desmos if you want, but 4 divided by 1 minus a half is really 4 over a half. 1/2 reciprocates and multiplies and gives you 8. So the answer is 8. The sigma would be to put just like you normally would, just like I did in the previous problem, you put the 4 here and the 1/2 here, you just put an infinity on the top to recognize that it goes till forever. Now right here, I put a little bit of an interesting problem because this one, I mean, look at the R value here, 12 divided by 9, or A2 divided by A1, is actually 3/2, which is divergent, right? Because that problem, unlike the one you just saw, the R value, 3/2, is greater than 1. Now that makes me remember that this needs to be between 0 and 1. So make sure that this number is between 0 and 1. But if it's greater than 1, it's divergent. And what that means is eventually you would actually add bigger and bigger in numbers. Eventually you would add infinity. So what that means is that this formula doesn't work. But you can still write a sigma down, right? You can still write down on this, you can still write down that 9 is A1, so I can still put 9 here. I can still write down that 3/2 is R, right? But this is going to go to infinity. Think about it. If I'm adding up 9, 12, 16, more, eventually I'm going to add in an infinite amount, which means that it would be infinity. This is not going to be on your test or on an SOL. This is really just an introduction to, some of you will be taking BC calculus, and that actually is part of that class. But our class needs us to find A1 and R when it's convergent. And on the SOL, I don't even think you have to decide if it is convergent or not. But I'm going to let you know how that works just so you know a little more. Okay, so what happens if they just give me sigmas, right? So the first thing you need to know about sigma is this 1 means plug 1 in. It doesn't mean use this number. So that's really important when you see this, like this 9 here, right? So you need to plug 9 in because 9 is the first term. Remember, A1 does not mean first term. A1 means the first term you're given, which is 9. So you need to put a 9 there. To find the n, we've done this quite a few times. This is not different from when we did arithmetic. You're going to take the top minus the bottom 15 minus 9 and add 1 to do inclusive subtraction. And so we have that 7 go in for n. So notice these aren't the same, but the 7 is that number and the 9 is the number you're given. So you have to actually find A9, right? And so A9 is found by taking 9 and plugging it into the equation they give you inside of sigma. So that would be 9 minus 1. And so A9 you would get from typing it into Desmos. All right, so then the R is the one thing you can count on, right? The R is always this, and that will immediately just go in here and here. And you type this whole thing into Desmos, so let's do that. So if I go into Desmos to show you where I got A9, -8, 2 to the 9 minus 1, obviously that would just be the 8th power. That's where I got the -2048 that you see here. To type the whole thing in, -2048. And then parentheses 1 minus 2 to the 7th, right? Please make sure you highlight this whole thing and then divide 1 minus 2, and you get the answer I got. Notice there's no comma. I didn't write one down here, and when you use Canvas, you're not going to use a comma either. All right, so then we have one that starts at 0. For some reason, this bothers kids a lot. That is your first term. Remember, first term means not 1, it means this and this are the same when you're using sigma. So then what you're going to do is you're going to put in your R, which is always the same. That's that and that. The 13 comes from taking 12 minus 0 and adding 1. To find A0, you put 0 in. That means you put a 0 here, which gives you 10 times 1/2 to the 2nd power, which is really 10 times a 4th, which is 5 halves. You can, of course, type that in the Desmos. All right, so I got 5 halves, and that's what went here. And so now what I'm going to do is we'll take a look at how to type all that in. All right, so going back to Desmos now. And so what we do there is we're going to have, to find A1, we did 10 to the times 1/2 to the 2nd power. Just remember to toggle the fraction button, right? 5 halves. And then down here, we have 5 halves. And then over here, we have a parentheses, 1 minus 1/2 raised to the 13th power, and then all divided by 1 minus 1/2. So this also, you get this mess, right? I mean, look at that messy number. But you get to use Desmos on the SOL, or when you take the SAT, you get to bring a calculator. So you want to toggle this fraction mode. It's actually 40,955 divided by 8,192. Don't leave it a mess like this. To do this on the TI, you hit Math and Enter twice. It'll do the same thing. All right, so number 9, same kind of deal. There were several kids that got confused because, like, what is A1? It doesn't matter what A1 is, because even if I told you that there is a 1 right here, it doesn't matter because A1 is really 0. So you got to put 0 in to the exponent. So you get 0 minus 3, which is -2/5 of -3rd, which would reciprocate and then cube. So you'd get -125/8. We can look at that in the calculator if you want. And then it's like the same old game, right? So this -2/5 is R, so I put it here. And then I type this in the calculator. Starting with that crazy term, right? So A0, again, would be -2/5, and then raised up to the -3rd power. And then to type the whole thing in, I would type in -125, oops, don't forget your -125 divided by 8, and then highlight the whole thing, and then divide by 1 minus -2/5. You're going to want to really practice that, right? And so you get gobbledygook, and then you clean it up by hitting that. So -625/56. Be careful typing that in. Maybe use some extra parentheses. All right, I was also asked to go over number 12. So number 12, the problem is I need to use the formula, but I don't know n. So this is AN, so I use the AN formula. A1 is 1. R is 7. You can just tell that I'm multiplying by 7, but it is A2 divided by A1. You divide by 1, which is superfluous, and then you log base 7. Now, I did have a kid say, again, like, I don't see log base 7. You're not going to see it in the scientific calculator. You have to go into the graphing, and it's right here. So functions, miscellaneous, log base 7, and then you type in that, large number, 16,807. So after you do that, you see that you get 5, and you add 1, and you get 6, then you can use the formula. But I did have one student say, what if you don't have a log base? Remember, what you're trying to do is saying 7 to what power is 16,008. So you can literally just play with it. Is it 7 to the 5th? Oh, okay, I just happened to get it. But what if I didn't know? And I was like, okay, let's start with the 3rd. Is it 7 to the 3rd? Nope. Is it 7 to the 4th? You know it's going to be an integer. So you can just play with that value until you get what they wanted, which was 16,807. So once you know that, then it's the same old game. 6 is in. You put 7 here. You type that into the calculator. You get 19,608. So one more of those, because people do somehow get really frustrated by it. So R in this case is not obvious. You would take 1,701 divided by 5,103. That comes out to a third. So it's the same game. This is AN. You use the AN formula. You put the 7 here. A1 is 5,103. You divide. You use Desmos or a calculator. 7 over 5,103 is 1 over 729. Then you log base a third, which poses its own new problem, right? So if I were to type that in the calculator, it doesn't actually go into Desmos. Watch. If I go in here and I type in log a third, watch what it does. 1/3. So you actually have to type that in a creative way. You would just use a whole bunch of 0.3333, a whole bunch of them. Okay, and then you type in 1 over 729, and you can estimate that it's 6, or you can just keep putting 3's in, right? It'll eventually say 6. Or you could just think about what it's saying. 3 to what power is 729? So just like start with 3 to the 5th. Nope. Is it 3 to the 6th? Nope. Let's see. Didn't like that. Let me try that again. 3 to the 6th. Nope, not. Oh, there it is. So 3 to the 6th is 729. So I know it's a 6. I add 1 to both sides. I get 7. Don't forget to add this 1. This isn't the answer. The answer is to solve for n. So you have to add 1. And then once you know 7, right, you're just doing the same game. You're taking 5,103. You're putting it in for A1 in the formula. And you're taking your R value you found here. You're putting it in the formula. And you're typing all that in Desmos. And you get 7,651. All right, we'll do 2 more. Okay. The first one is, how do I do this problem with this crazy big number? Start by writing down the formula, right? It says use S. So I wrote down the formula for S. It told me S of 10 was this, so I put it S10 here. That 10 also goes here. And then I take that number, I write it down, even though it's ridiculous. I'm solving for A1, so that's no big deal. I take the R value, which they gave me, and I put it here. And then this is the part that some kids get lost on, like, how do I go from here to here? You type this entire mess into Desmos, right? So if I type that whole mess in there, watch. I have 1 minus negative 1/4 raised to the 10th power, okay? And then the whole thing divided by 1 minus negative 4, and I get 209,715. You don't play with this. You type it into Desmos. And then you got to remember what you're doing. You're solving for A1, so then you divide that on both sides, and you can kind of tell it actually just comes out to 10. But if you need to use Desmos for that, you can. All right, last problem. What if I need to solve using the infinity formula? How do I know? Well, just like before, do you see how it says S infinity? Just like over here, it said S of 10. S of 10 is finite, so I use this one. S of infinity is infinity, so I use the infinity formula. I write it down. I plug in what I have. A1 is 18, so I put 18 there. R is what I'm trying to find, so I don't put that in. And so then I have to solve this equation. And I use my skills from rationals, right? So the way I solve this is I multiply by it here to cancel it. I multiply it over here. It drops down. And then I can distribute if I want. More efficiently, I would divide, canceling it here. I reduce this to 9/16. Don't forget, your answer is not done. You have to subtract 1. And then when you subtract 9/16 minus 1, you're really subtracting 16 over 16. So you get negative 7/16. You divide by negative 1, and that is your answer. And you can even check it, which is kind of cool. Like you can always go back into Desmos and say, hey, is 18 divided by 1 minus my answer 7/16? Is it what they told me it was? Look, they said it was supposed to be 32, and by using that R, I got that value. Well, hope this was helpful, and work hard. It seems like a lot, but it's just, again, write the formula down. It's not so bad.